Thermodynamics can be described as the study of energy transfers. And in this section, we'll review the laws of thermodynamics. Whereas microscopic properties describe the motions of atoms and molecules individually, macroscopic properties of a substance describe the overall large-scale properties of that system. Examples are pressure, volume, and temperature. We had already looked at pressure and volume in a previous video, and here we'll look a little bit closer at what temperature is. A qualitative understanding of temperature comes from our own sense of touch. But humans, as it turns out, are better at judging differences in temperature than actual absolute temperatures themselves. So our skin is sensitive to the rate of energy transfer. Which of the following are examples of humans sensing differences in temperature? A person whose hands have been in the cold for a long time claims that room temperature water feels extremely hot. Are they sensing the absolute temperature of that water, or are they sensing the rate of exchange of energy? If you think about it, you'll realize that they are sensing the rate of energy exchange. What about this? A person claims that carpet is warmer than linoleum, even though both materials are at 50 degrees. The reason that they're sensing the linoleum feels cold is because they're sensing the energy leaving their body when it flows to the linoleum. So that's another example where humans are actually sensing the differences in temperature rather than the temperatures themselves. So we have to have devices which are capable of conveying what the true absolute temperature of a system is. All thermometers make use of some physical property that exhibits a change when the temperature changes. For example, the volume of a liquid. It changes with temperature. And examples would be a mercury or alcohol-based thermometer. The length of a solid can change depending on its temperature too. A thermostat would be an example of a device that uses that. And there are others as well. The pressure of a gas at constant volume will change with temperature, and the volume of a gas at constant pressure will change with temperature. To calibrate a thermometer, we would place it in contact with some environments that always retain a constant temperature. For example, a mixture of ice and water. On the boundary between the liquid and solid state of water, the temperature is always constant. It's 0 degrees Celsius or 32 degrees Fahrenheit. Similarly, the boundary between the liquid and gas phase always remains constant as well. That's 100 degrees Celsius or 212 degrees Fahrenheit.